Good morning, everyone. How are we doing today? Hopefully everyone's internet is better. Bueno? Is that correct? Good? Alright, still missing a few people. I agree. Gavin's got the right idea. Let's do some circles. Sam is very excited today. It's always good. You beat your personal record. What's your personal record in what? You finished The Office in 1 month. Speaking of The Office, Abby, it is your birthday. It is a statement of fact. I'm glad. I'm glad you did. I figured you would. Took some time to craft, but it was a good video I made for you. Oh no, you can't now. We always have to have good jokes. Oh, it looks like this. I don't know why this keeps doing this today, like every 5 minutes. I mean, it's very easy to pull back up, but every now and then the screen might go out. If so, I'll just do that. Let's see. We got a lot more people in here now. We're going to continue with inscribed angles. Remember, tomorrow there's not going to be I'm not going to do a live stream. I'll give you time to work on the assignment if you haven't done so already. I think I got some people who handed it in already. I did all the grades as well. If you go in the school tool and you see, if you're curious on the test grade, for anyone who did the quadrilateral test and how I came up with your number, I'll gladly tell you, how I did it. I can briefly explain what I did for that grade, because like I said, it was meant to boost your grade if you completed that assignment, and that is exactly what it did. I took into account your previous 2 test grades of the quarter, because if you remember, in this quarter we had a midterm and we had the similarity test, and basically what I did was, let's just say for whatever reason you got your average on those 2 tests were like a 70, and then you got an 80 on this test that you handed in, the quadrilateral one. Then I boosted that score up an additional 10 points. So everyone's got boosted in a way. Some people did really well. They got like a 90 on the quadrilateral test, and their test average was like a 70. So I gave them 100 on the test. So I gave everyone higher what they would have gotten, but I also made sure that no matter what, the test score was higher than the average of the previous two tests. Because if the average is higher, if the test is higher than the average of the previous two, no matter what, everyone's score would go up, your overall average. And that's how I kind of computed the average. Some people had averages in the 90s. So if that were the case, you could have gotten over 100 on this test. I think I did give 110, 105 for some people. No one could have gotten lower on what I put in School Tool compared to what they got on the test. So Ryan, no, if you got a 90, I did not put in an 80 for the test. If you got a 90 on the test, but your test average on the previous test was, say, an 80, I probably gave you 100. All right. So that's just kind of how I computed the grade. If anyone wants to go in School Tool and look at what they got, because what I put in Google Classroom is not what I put in the grade book. What I put in the grade book is higher than what you saw in Google Classroom. So if there's any questions with that and kind of how I figured out that grade, you can look at that. I graded all the weeklies. Like I said, I was going to grade with leniency, so there was a lot of 20 out of 20s, and a lot of people had more than one mistake, and that's fine. So a lot of people got 20 out of 20s, which is great. A lot of people got legitimate 20 out of 20s too. Some of them looked really, really good. One of the, I think, funniest mistakes was a lot of people on number 2 rounded to the nearest 10th, and I think it was out of habit, but it did ask for 2 rounds to the nearest 100th. The progress reports will only have comments. I think I don't know exactly what the progress reports are going to be doing. I think they might have like the fourth marking period grade there, which might, I don't know. I have not put a number grade in, but it might do it automatically. But I did put in comments for everyone. So if you have any questions about really anything about that progress report that's coming up or any assignments, please just ask me. And we have another assignment in there. The homework. Make sure you get that done. I know pretty much everyone who's tuning in live is completing the assignments, so it's really not meant for you guys. For the about 10 people who are not tuning in on a regular basis, they're the ones I'm more concerned about. There's about 5 people who I'd like to see a little bit more work from, or just see live. But that's kind of all my general announcements. If there's any questions, let me know. You can look in School Tool to see your grade, or you can ask me what I put in the grade book for you for that extra credit assignment and or weekly. But everything should be returned if you handed everything in. All right, we're going to kind of jump right into just some practice. Like I said yesterday, we're just going to practice some of the examples. We'll finish inscribed angles today. We'll learn one new thing with inscribed angles, which is going to be inscribed quadrilaterals, which we see right here. We'll do all this, and then we'll have an off day tomorrow, and we'll kind of finish up the week on Friday. All right, number 11. So we are thinking about this 2-to-1 ratio that we have going on. So right here is really the angle that we want to know, arc AC. If we know that angle, we can easily figure out the angle inside that circle, that inscribed angle, angle ABC. But we don't know it, so we're going to have to use these outside angles to help us out. And really good that those 2 angles are the rest of the circle. So we're going to add up those 2 angles. So 92 plus 162, I think that's going to be 254. We're going to subtract that from 360, and we get 106. So if that angle is 106, remember the most important thing to remember from yesterday is this 2-to-1 ratio. The fact that we can cut this angle in half. We can cut the arc in half, and that's going to be the measure of the angle in here. So we cut that in half, and we get 53. So this angle in here is 53 degrees. The question is asking us to solve for the value of x, but now that we know that that is 53 degrees, and it's 7x minus 10, we can set them equal to each other. So we get 50 or 7x minus 10 equals 53 degrees. And then we'll just solve this. We're going to add 10 to both sides. We get 63. And then divide 7 by both sides. We get x is equal to 9. And that is our final answer. And for anyone wondering, you could go the other way around, which I know we haven't really done, but you could double the expression. You could double this right here. If you double this, this would be 14x minus 20. You could set the 106 equal to 14x minus 20, and you'll get the same exact answer. You can go either direction with it, as long as you know what to set equal to each other. But either way is fine. So a lot of it is just kind of figuring out, you know. So you got a 90 on it. Was that my actual grade on it? Like I said, it depends on what you got on the previous two tests. Depends on what your average was. So if your average was already a 90, then I gave you higher than a 90. If your test average was like 100 and you got a 90 on this test, that means I gave you over a 100 on the test. Everyone's average went up if they did it. Then I probably gave you like a 105 is my kind of guess. I can look it up at the end of the stream if you want, but I'm not going to look it up right now. Ask me at 11:40 and I'll tell you exactly what you got. I can even just message it to you personally if you don't want me to say it. But that is likely what I did. Let's take a look at number 12. So same idea. We're going to just figure out what the measure of that arc is. So this arc right here is 5x plus 21. We just want to figure out what that measure is. So we're going to use the inscribed angle rule. We know that that upper arc is 120. We can easily figure out what arc QS is by using our inscribed angle rule. But now that we're going from angle to the arc measure, this is where we double it. So we double that and we get, I think that's 134. So if that's 134, now we can easily figure out that other arc because we have this circle only has 3 arcs. So we have the 120 plus 134. That gives us 254. And then we could take that 254 and subtract it from 360. And we get 106. So we can take that 5x plus 21. Set it equal to 106. So then we can subtract 21 from both sides. And we get 85, which is great. Obviously, that's going to be divisible by 5. We divide both sides by 5. And I think that's 17. It's all pretty straightforward. I mean, as far as the algebra, like I've said before, many times, we've done this type of algebra many times before. It's whether or not you can apply the theorems to these geometric figures. Let's look at some more challenging ones. A little bit longer, which is why they give you more space. They give you more expressions, and we just got to figure out how, and it looks like, by giving us the expressions, we have to either double or cut one in half. Depends on where they are. So make sure that you label everything carefully. I know the diagram's not super big. Some of you write pretty big as well, so it's hard to write on the diagram. As long as you can write it in there in a way that you understand it. But it says that angle FGH. So definitely want to take extra attention into the thing that they're giving you, because they can give you angles and arcs and so forth. So angle FGH is this guy right in here, which we're going to call 6x plus 21. And then they give you the measure of arc FJH. So FJH, so So where's FJH? Let's just highlight where that is. So remember, order matters a lot with this. So you have to go to J first before you hit H. So FJH. It is the arc. It is the intercepted arc, which is good. That means there's a direct relationship between both expressions. So we're going to write in, what was that, 17x minus 28? And then they want the measure of, what do they want? FJH. They want the actual arc, which I have highlighted already. They want the value of that arc. And I mean, use some common sense here. The diagrams, we've always said, they're not drawn to scale, but they're pretty close. That arc looks pretty big. It looks more than half the circle. I'm expecting an answer probably just over 180 degrees. So I wouldn't be surprised if this answer is around 200 degrees-ish. Try to use some of that logic to it. I know, some diagrams are wildly off, but usually they've been pretty good most of the year. You have two options. You can double one or cut one in half. It really doesn't matter. I'm just aware if I'm going to cut one in half, which if you were cutting one in half, it would be the 17x minus 28. If you divide by 2 with an odd number, you will get a decimal. So because of that reason, some people like to double, because if you double whole numbers, you'll never get a decimal. So we can do that, but either one would be fine. So I could write two expressions here. If I'm doubling, you double the 6x plus 21, and you get 12x plus 42. If you were cutting in half, I think it's 8.5 minus 14. You can use either expression. You just got to choose one of them, well, one pair of them, and set them equal to each other. I'll choose the one that does not contain a decimal. I'm going to take the 17x minus 28, and we're going to set that equal to 12x plus 42. And we'll just do our algebra from here. Subtract 12x from both sides. We get 5x. Add 28 to both sides. So that's going to give me 70. We're going to divide both sides by 5. And you get a value for x, which is 14. Again, not the final answer. We will need to plug in. Now, because these two expressions, they weren't equal to each other, so I would say it does matter which one you plug into. And since this is a direct answer, 17x minus 28, that's the one I'm inclined to plug into. So 17 times 14 minus 28. And yes, Gavin typed out the answer well ahead of time. Absolutely correct. When you plug that in, you do get the measure of FJH, arc FJH, is equal to 210 degrees. Almost right along the lines of what I had predicted before I even did the problem. Just thinking about the size of the arc and just thinking about, okay, this looks like more than half the circle. It should be over 180 degrees. So I would say that 210 is completely reasonable for the size of that arc that I'm seeing right there. It's always good to have that kind of that recognition before you kind of start a problem. Because if you got something less, I become a little skeptical. I kind of recheck my work and see, is the diagram really that off? That's stuff we've been doing all year. That recognition kind of stuff. Let's see. We'll keep going. Number 14. Again, they're telling me the angle of STU, so we're going to make sure we label the correct thing. So STU is 5x minus 16. And then the measure of arc SU. Measure of arc SU is 12x minus 50. And what do they want us? They would just want us to find the measure of angle STU. So that's actually pretty straightforward. That's not too bad. They just want us to find the angle. Obviously, and the most common mistake I would see is two people who just set this equal to each other. But make sure you're going to double one or cut one in half. In this case, you can do either or. Because the 12x minus 50, they're both even numbers, cutting it in half should be fine. I'll go that route. I'll cut this in half. Just make sure you cut everything in half. So 6x minus 25. That is what I'm going to set equal to each other. These two expressions right here. So you get 5x. Actually, I'm going to do the 6x first. 6x minus 25 equals 5x minus 16. Minus 5x from both sides. Add 25 to both sides. And you get 1x equals, which is great, we don't have to divide, 9. Nice. And then we're going to plug in. Technically, you could plug into either expression you have in here. I like to plug in the one that they gave me, but it really shouldn't matter because I have 6x minus 25 and 5x minus 16. You should be able to plug into either of them, but I'll plug into the original, which was 5 times 9 minus 16, which is 45 minus 16. So I see a few people in chat. I'm going to agree with the 29s here. So the measure of angle, what's that angle? F or STU is 29 degrees. I see. Yes, if you forget to double one of them, yeah, your answer will be off. Because basically what we're doing is you're distributing, basically. When you cut in an expression in half or you double one, I mean, we cut in half, so mathematically it really looks like this. I'm just not writing it out. And you'd have to, algebraically, you'd have to distribute that 1/2. Same thing if you put a 2 in front of there and you have to double it. That's why, we're just, we're distributing without actually saying distributing. All right, we got 2 more, and then we're going to go on to the next page. So we got angle ABD is 6x plus 26. 6x plus 26. And angle ACD, that's this one up here, is 13x minus 9. Find the measure of arc AD. So I like this one because it's using a completely different rule than we've been doing. It's not 100% using that 2-to-1 ratio, although that is going to come up in this problem. What I'm noticing is, what is the relationship between these two angles? And you might have remembered it from yesterday. These angles are congruent because look at the arc they're intercepting. This goes to this arc, the one that we're looking for, arc AD, but the other angle they gave us goes to the same exact arc. And if 2 inscribed angles go to the same arc, that means the angles are congruent to each other. So just as a refresher, this is the overlapping arcs section at the beginning of our notes. If you just need to see that rule. Sometimes it's a little hard to recognize because the diagram is a little bit more confusing. But if 2 inscribed angles intercept the same arc, those angles are congruent. So with these, no cutting in half, no doubling, those angles are already congruent to each other. So set them equal. 6x plus 26 equals 13x minus 9. We'll do our algebra. We get 35 equals 7x. So x is equal to 5. Obviously not done there. We are going to need to do some plugging in. We do need to find the arc. We're not asked to find one of the angles, but we have to plug in for one of the angles. So now this is where we are now. We have to use the other rule, which is that 2-to-1 ratio. So we're going to have to find one of the angles and then double it. So I like to plug into whichever one I would consider easier. I think the 6x plus 26 is easier. Doesn't matter which one you plug in for. They were congruent. So You can plug in for both, again, to check, but I'm going to plug in for this one. So 6 times 5, oh, that looks really messy. So that's 30 plus 26, which is 56. So these angles in here are 56. And I'm assuming that 13 times 5 minus 9 is also 56. And then that means, last step, the value of the arc. From inscribed angle to arc, double it. So 112. So I like questions like that. There's a lot of moving parts to it. It made you apply 2 rules, made you do some algebra, plug in. Overall, I think it's a very good problem. And we got one more. Number 16. If KJL, that's angle KJL, is 3x plus 2, so we'll put 3x plus 2, and KLJ, it's the other one, is 7x minus 32, find arc KL. Really like this one because it's also using 2 rules. It's using 2 different rules, though. Well, at least one of them is different. You still need to know basically where angle J is, so KJL. If you know this angle right here, and we had doubled it, you have arc KL. Can you zoom in on 15? So there's 15 for you. But if in the previous one, if I know the angle J and I double it, I'll have my answer. So I need to figure out what the value to that angle is going to be. So this one is, you have to recognize that the triangle there is a right triangle because angle K is intercepting a semicircle or a diameter. Therefore, this is a right triangle. If it's a right triangle, all the angles must add up to 180 degrees, and we know that the value of that one is 90. Or, in a right triangle, we know that these two must be, they add up to 90. So we're going to take those two and set them equal to 90. So this is one we're not setting anything equal to each other. We're not cutting anything in half, doubling anything. We're taking the 2 expressions and we're adding them together because we've determined that they are complementary. And that's what you would need to do with this one. And they could easily turn some of these questions into like SOHCAHTOA questions if they start giving you some of the values of the sides and whatnot. Because we did a whole unit on right triangles alone. So they could do Pythagorean theorem, they could do SOHCAHTOA, any of that stuff. They didn't give us any sides, so it's unlikely going to be either one of those. This is really the guide to our solution. So combine like terms. 10x minus 30 equals 90. Add 30 to both sides. And then divide both sides by 10. Now, it doesn't matter which one we plug in for. We should be plugging in for the one that we have labeled at J. So we're going to plug in 10. That's a nice, easy plug-in. 3 times 10 plus 2. So that's 32. Last step, that's an inscribed angle. So all we got to do is double it. So arc KL is 64 degrees. Any questions with that stuff? Because we're gonna continue with inscribed angles, but it's just gonna have an additional, basically an additional rule, a new exception to the rule. we're going to move on to this page right here. Isn't x equal 12? Yes, it is. I have x is 12. Oh, did I do 3 times 10? Yep, I did. I don't know why I did that. Good catch. So that just changes things up just a little bit. Thank you for catching that. So was that 38 instead? 36, yep, 38. Which 38 doubled is going to be 76. Good, thank you for that. My mind might have just been looking at this 10x and have done that. But thank you for catching that. All right, inscribed quadrilaterals. So for an inscribed quadrilateral, and we just did a whole unit on quadrilaterals, which is good. So kind of refresh our memories on some of the properties. Now, these aren't parallelograms. They could be. These are just going to be generic quadrilaterals, and you can kind of see that from the diagram. Some of them look really, off. There's no like opposite sides, parallel and congruent, no diagonals. It's not parallelograms. So the most important property to kind of remember from quadrilaterals is that the sum of all their angles is 360 degrees, which is great. It's the same as a circle. So all these angles in here, A plus B plus C plus D, all 4 of them add up to 180 degrees. Sorry, 360 degrees. As well as the circle. But if it is inscribed in a circle, this does limit some of the conditions that are possible. There are only specific types of quadrilaterals. The quadrilateral is limited into its shape if it is inscribed in a circle, and that does have some certain consequences to it. And we can use the rules of inscribed angles. And it's because there's a lot going on in the diagram, sometimes it's hard for some people to see. But if we were to choose, I'm going to just choose angle D for a moment. Angle D is an inscribed angle. Just angle D by itself, not even thinking about the quadrilateral. That makes arc ABC. We agree that arc ABC is going to be whatever twice of angle D would be, no matter what. So if angle D were 50 degrees, that arc that I highlighted would be 100 degrees. But if you now go on the opposite side to angle B, and because these lines connect, the intercepted arc is the rest of the circle. And that's important. If the intercepted arc is the rest of the circle, that means all 360 degrees of the circle have been accounted for. Even though they're different, this is going to be twice of angle B, which tells me something about angle D and angle B. If the whole circle is 360 degrees and the inscribed angles are half of that, that tells me that opposite angles must add up to 180 degrees. So if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. If that explanation confused you, that's okay. It's not the easiest thing to visualize. If that made sense to you, great. But you can just kind of understand that, okay, opposite angles are supplementary, and if you know that, you are going to be mostly good to go. So that means in our diagram that angle D Oh, actually, I won't write and. I'm going to write plus. Angle D plus angle B equals 180 degrees. And you could do the same sequence of, with angle A and C. Angle A and C are still going to represent the entire circle, so we can cut that in half. So angle A plus angle C equals 180 degrees. So again, it obviously a pretty easy rule, but it's just another one for us to remember. If you start seeing quadrilaterals inside of a circle, this is probably the number one rule that is going to come up that you're going to have to consider. So in number 1 right here, they just wanted to know what angle J is, angle K. So we will just use opposite angles. So these are the opposite angles. They must add up to 180 degrees. So very simply, take 180, we're going to minus 45 from it, and we get 135. So 135. Then these two are also opposite angles, so they're supplementary. So angle J must be 88. And then you can double check for yourself. Do all 4 angles add up to 360? And they should. They always should. So angle J, 88. Angle K, 135. So number 2, they only give you one of the angles, which is fine. But then they give you some arc measures to help you figure out what those angles can be. The first thing I would find, and the easiest thing to find, is angle S, because it is opposite to Q, and that is what they gave you. So we can just do our supplementary relationship. We should get 87 for this angle right here. Then to handle those two arc measures, well, now I want to start looking at the angles, and I want to think about the inscribed angle rule. So if you look at angle P, the intercepted arc is this one, which we don't know the value of that arc, so it's not too helpful. But if you go to the other side, angle R, well, it's intercepting here to here, so it's this entire arc, which is great. This arc we do know, we have to add up the 126 and 90, so you would get 216 for that arc. So now you can use the inscribed angle rule to just cut it in half to figure out the value of angle R. So angle R is going to be 108. So if we know that's 108, angle P directly across from it must be supplementary, which should be 72. Which also makes sense. If that's 72, the arc across from it, arc QS, would be 144, and that's 360 degrees around the entire circle. So that you just got to recognize that that inscribed angle rule is still at play, that you might still have to do that 2-to-1 ratio to figure out some of the angles or arcs or whatever. Because I'm sure in some of these, they're going to ask you to find some arcs. Oh, no, they don't. Okay. Well, that makes it easy. But I can fill in my answers right here. 72 degrees, 108, and then 87. All right, we can do a few more. Taking a look at number 3, same idea. They gave us some arc measures. We have an angle. We're going to do the same exact thing we did before. So I have the 51. My eyes kind of look at that one right first, so I can do the opposite angles first. So 51. The supplement of 51 is going to be I think it's 129. And then I'm going to handle the same one. So I notice I have the 101 and 67. So I'm going to use this inscribed angle right here because the intercepted arc comes from here, passes V, goes right to W. So this arc right here. We add those together, we get 168, and that is what I would cut in half to figure out angle X, which I think is going to be 84. So if that's 84, we can jump across to the other side. The supplement of 84 is 96. So angle V, 96. Angle W, 129. And lastly, angle X, 84. And we'll do one more, one where we got to find all the angles in the quadrilateral, which this is utilizing basically all the angles you could find by using inscribed angles. You can use the opposite angles or supplementary. There's a bunch of different methods you can do for this one. And the first thing that I would do personally is, as I look at the diagram, you have this arc, the 39, you have the 61, you have the 147. The only thing you don't have in terms of arcs is AD. So you might as well just find it. Because if you have all the arcs, it's going to be really easy to figure out all the individual angles. So I'm going to add up the 39, the 61, and the 147. You add them all up. So that whole big arc from here to here is, I think it's 247. And we're going to subtract that from 360. And we get 113. So angle, or arc AD, is 113 degrees. And then I'm just going to start looking at some of the inscribed angles. And because you have all the arc measures, it doesn't really matter what angle you start with. You can choose any of them, and you'll have any of the arcs that you want. I'll start with D. So angle D extends out to the 39 and 61. So collectively, those two angles are going to be, I think that's just 100. That's nice and easy. Because if that's 100, that means angle D is 50 degrees. And then that means the angle opposite to it, I mean, you could check the opposite angles again. Shouldn't matter, but you should get 130. And that makes sense, because 113 and 147 is twice that, 260. So, and now we just do the same thing with the other angles. Diagram's getting a little messy, but that's okay. I'll find angle A. So angle A is this side and this side. My inscribed angle is the 61 and 147. So 61 plus 147 is 208. So I can take that 208, cut that in half, and get 104 for angle A. And if that's 104, opposite angles are supplementary, so jumping across, angle C should be 76 degrees. And then we can just fill in our answers. Angle C is 76, and angle D is 50. All right. But it is 11:40 right now. So that's going to conclude today's stream. As always, you guys have questions. You guys can stick around, ask me anything you want. And Ryan, I can message you the grade that I put in for you. If anyone else wants to know anything about either grades, assignments, just ask me. All right? But thanks for coming, and I'll see you tomorrow. And don't forget, on your way out, wish Abby a happy birthday. You're welcome. Do you need it back up? Let me know when you're good. I was gonna message Ryan. It's great. Yes, if you stick around in here, I can send a private message through Twitch, which I'll be able to see. If you're watching from a phone, I think it's hard to see the messages, but unless you just want me to say them, but. Oh, we're not having one tomorrow. Did I say I'll see you tomorrow? I won't see you tomorrow. Thank you for that, Jess.